Lesson 3.6 is on proportional and non-proportional relationships. So in this video, you will learn to write an equation for a proportional relationship as well as for a non-proportional relationship. So what is a proportional relationship? It's a relationship where its equation is of the form y equals kx. So we talked about this in the last lesson when we talked about direct variation. So basically a proportional relationship is like a direct variation equation, okay? So it goes through point 0, 0, goes through the origin, and it also has just a slope, kind of basically of k. So the ratio of the value of x to the value of y is constant when x is not equal to 0. Okay, so if I want to find proportional relationship equations, let's analyze this information. So it says the table shows the number of miles driven for each hour of driving. If you graph the data, I already have it graphed here, but 150, 2, 100, and 3, 150, 4, 200. Okay, what can you deduce from the pattern about the relationship between the number of hours and of driving h and the number of miles driven m? So if we're looking at this, what kind of relationship is this? Because if I were to draw a line going through my points, and I get a line, if I were to connect my points, I get a line, that means it is a linear relationship. And it goes through the origin, so it's also a proportional relationship. Okay? So if we want to write an equation to describe this, we're going to look at our data. So this is going up by 1 each time. And then these are going up by 50. So if I want to know, remember my equation is y equals kx. If I want to know what my k is how much the dependent variable changes by over the independent. So looking at this, the number of hours and the miles driven. The number of miles driven is going to depend on how long they've been driving, right? So my miles is my dependent variable and my hours is my independent variable. So when I write my equation, y equals kx, k is going to be 50 over 1, or just 50. So y equals 50x is going to be my equation. Or if I want to do it in terms of m and h, it's going to be the number of miles driven is going to be 50 times the number of hours. Okay, so this is what we would want to go by. Okay, so use the equation to predict the number of miles driven in 8 hours of driving. So if our equation is m equals 50h, this is my h. So that means that I'm going to have m equals 50 times 8, and I get m equals 400. So 400 miles. Ooh. You would expect to be driven in 8 hours. Okay. If we have a non-proportional relationship, that means it's not going to be of the form y equals kx. But it's still a line, it just doesn't pass through the origin. So that means it's going to maybe have something else. So if we were to look at this, these are points. If we have our x values and our y values, we have 1, 1, 2, 4, 3, 7, 4, 10, and 5, 13. So if we're looking at this, the x values are going up by 1 each time. And the y values are going up by 3. So you would think that your k would be 3 over 1. So the dependent variable is increasing by 3, independent is increasing by 1. Change in y over change in x. It's also the slope. Okay, so, but if we were to look at the equation, if I had the equation y equals 3x, because this is 3, so just putting in 3 for k, does this equation work? So if I had x values, what does 3x give me if I do 3 times x? I would have 1, 3, 2, 6, 3, 9, 4, 12, and 5, 15. But my y values, what I should be getting is 1, 4, 7, 10, and 13. So if I'm looking at this row here compared to this row, what's the difference between them? How is it off? Well, 3 and 1 is 2 less than 3. 4 is also 2 less than 6. 7 is 2 less than 9, and so on. So it would make sense that each of the numbers, if I multiply by 3 and then subtract by 2, I'm going to get my y value. So x times 3 minus 2 gives me the right equation. Okay, and then they just said to put this into function notation. So function notation, instead of using y, we're using f of x equals 3x minus 2. And that's it for this section.